I hope you guys are doing well. DJ Bros, Sahiba, Anjali, Yogesh. How are you guys? Today we are going to see electronic devices chapter, and in which we'll cover a few important questions. And you know what? This chapter is very important. Why? Because it's very easy. If you are getting 1-2 questions in JEE mains, definitely you will able to solve those questions for sure, 100%. Because level is very less, right? So how are you guys? Yogesh, Anjali, Shaiba, DJ Bros. Welcome to the session. Okay, now this is a question of JEE Main 2018. Hello, Sandeep. JEE Main 2018. Akshat, the Greek god. Okay, so here, cute princess. Welcome. This is JEE Main 2018 question. Yeah. So how was your result, guys? So don't worry, we have one more exam. I mean, mains, one more main, and then advanced exam. So you guys can prepare for that, so that at least you will get good percentage once more, and at the end we know no only one gets counted, whatever is the best. Now here in this question we have to find current. You know what, guys? If we have resistor and if we have a battery and we want to obtain current, and assume this voltage as 12 volt, assume this 2 ohm. In that case we all know current is equal to V by R, that is 12 by 2, so this is 6 ampere. This is very simple. But what if we are inserting any diode in any circuit? So you should know how to replace the diode. For example, if we have a diode, hello Meghna, Utkarsh, okay Unnati, I hope you are doing well. Yeah, good evening. So guys, this is a diode. Actually in examination you will get 3 types of question. First is ideal. First condition is ideal. Second, made up with silicon diode, and third one is made up with germanium. In that case, what you need to remember, whenever it is given that diode is ideal, so these 2 points A and B, so we have to replace this diode by short circuit. 75. Okay, good. So A point and B point, so we have to short. If it is given that silicon diode, so what we have to do, we have to replace this by a small battery, you can say, of potential 0.7 volt. And if it is given that germanium, in that case you can replace this as a potential of 0.2 or 0.3, it's up to you, but mostly we take 0.3, so I've written 0.3. So this is the basic thing. So once you are able to convert this diode into their corresponding equivalent circuit, then you can solve any circuit. For example, in this particular circuit, it is given that the reading of ammeter for a silicon diode in the given circuit is, okay Meghna, that's very good. And what was your marks? Okay, silicon diode. So it is silicon diode here. So we have to replace this by a battery, and configuration is like this. So we can say it is like this is 0.7. Now this is a very simple circuit. Instead of diode, we have replaced this diode by its equivalent circuit. Now we can apply KVL and we can write the value of current. Why we are obtaining the value of current? Because the question is obtain the reading of ammeter, and it is measuring current, so we have to obtain the value of current in this particular circuit. So current directly, what we can say, I is equal to 3 minus 0.7 by 200, right? So on solving this, you will get 11.5 milliampere. So I hope this thing is clear to everyone. Any doubt in this particular question, you guys can ask, because question may be framed anyway. But what you have to consider is this point. If diode is ideal, you have to replace by short circuit. I mean, simple plain wire. If silicon diode, then 0.7 volt and polarity in this way only. And germanium, then 0.3 volt. And rest is only circuit, and you guys can solve circuit. Is this thing clear to everyone? Now moving next question. Okay, guys, please tell me the answer of this particular question. Can anyone answer this question? Here we have four input: A, B, C, and D. Okay, and this is the output. This one is output. Question is, A, B, C, D are inputs to a gate and X is its output. Then, as per the following time graph, the gate is. So which is, which gate, A, B, like AND gate, OR gate, NAND gate, NOT gate, represent this one. So you should know their truth table. So usually, if I'm saying OR gate, so as name suggests, OR means if we are getting any one, like if I'm saying 1 0 1 0 1 1, its output is 1, and 1 0 0 0 0 0, still it will be 1. So what is the property of OR gate? So whenever you are saying any 1 is there, at the end output will get 1. Or even the most famous truth table, like 2 input, options are not clear. It's very simple. Now we have 4 options: AND, NAND, or NOT. Which gate represent this particular combination output? Let's check. I'm explaining this thing, don't worry. So if we want to draw the truth table for OR gate, in that case, what we can show, 2 input. Hello Divya. I1, I2, let's suppose 2 input, and this is the output. Okay, we know that OR gate, if it is having 2 input, so 0 0 0 1 1 0 and 1 1. Hello Afia. What about the output here? So can I say this will be like, hello Kalpana, this is 0, this is 1 1 and 1. So this is the output of OR gate. This is a truth table, actually truth table of OR gate, and this corresponding, this is output, right? Now what we can conclude from this truth table, that in case of OR gate, whenever we are saying input as 1, definitely output will be 1 for sure. That's why it is OR gate. Yeah, welcome Sonakshi and Prinik, Priyanshu. Right now, what about NOR gate? So here we need to just invert the output of OR gate, we'll get the output of NOR gate. So in this particular question here, this will be 1, this is 0 0 and 0. So this is the output of NOR gate. Similarly, we know truth table for NOT gate. Okay, is this not visible, Sonakshi? Fine, so we'll do that thing. We'll modify this thing, don't worry. Okay, so now I hope things. Hello Karthik. AND gate. I hope now this is visible. If we want to write AND gate, so truth table input 1, input 2, okay, and this is output of AND gate, obviously. Now 0 0 0 1 1 0 and 1 1. Its output is like 0 0 0 and 1. So what is the condition? Yes, I remember everyone. Okay, so what is the condition for AND gate? All the input must be 1 only, then output will be 1. Okay, GK. So 1 1, that is 1, right? So what about output of NAND gate? This will be 1 1 1 and 0. Yeah, welcome Gurmil. So this is all about Kalpana Singh NOR gate 1 1 1 0. So you want to know output of that NOR gate. Okay, here NAND gate. Okay, you guys are saying final answer for this. Okay, NAND gate, no? Right. So this is a NAND gate. Yes, 1 1 1. Output will be 0. Correct. So this is about NAND gate. Now coming to this question here, 4 inputs A, B, C, and D. So you know what? Whenever signal is like this, right? So it is clearly showing that this is correspond to 0 and this correspond to 1, this correspond to 0 and so on. So here we can say 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 and so on. Similarly, this is 0, 0, 1, 1, 0, 0, 1, 1 and so on. This is 0, 0, 0, 0, 1, 1, 1, 1, 1 and so on. 0, 0, 0, 0, 0, 0, 0, 0. Why I have written multiple times? Because what we are taking single bit. So I'm showing you that by dotted line here. This one, then this one, then this one, and then this one. Okay, let's take first configuration. First configuration, can I say 0, 0, 0, 0? And what is the output for this configuration? For this 0, 0, 0, 0, what is the output? Again 0. So output is 0. Now I'm taking second input. It is 1, 0, 0, 0. How I'm writing? It's very simple. See, 1, 0, 0, and 0. So output is this time 1 now. This is again 1, 1, and so on. So this time output is 1. Now let's take one more input. So this time 0, 1, 0, and 0. So now input is 0, 1, 0, 0. What about output this time? Tell me for this y1, because this is the output now. This is the output. This corresponds to output only in this, because question is given that x is its output. So this is the output. So in first case it is given that output is 0, in second case 1, then third case 1, fourth case 1, and so on. That's why. What about the output of third? So third output is 1. So again this is 1. Okay, that's good. And so on, we can proceed. So let's try to figure it out. Are we getting any clue, any hint by this? So what we can see in this, any one output is 1, any one output is 1. But if all are 0, in that case output is 0. So which gate it represents? Tell me. Which gate it is representing? OR gate. Yes, Karthik, very good. Seems like it's genius, Karthik. So OR gate is the correct answer. Yeah, Afia as well. Yeah, Kalpana, Afia, you guys are giving the correct answer. So OR gate. So this is a way how, even question may be in any frame, maybe any graph. So procedure remains same, and you should know its truth table as well. Once you know that, this question will be very easy for you to solve. Not very difficult question. Any doubt, you guys feel free to ask. Then I will move on. I'm moving towards next question. Okay. Now, quickly respond to this question. Which one is correct for this particular question? The forward biased diode connection is. In which case diode is forward biased? Yeah, thank you very much. Now, what about this question, guys? The forward biased diode connection is. A. Karthik is saying A, Afia is saying C. Okay. Kalpana is saying C, and Meghna is saying A. Wow. So what I can see, I'm getting mixed response. Apurva is saying C as well. Okay. So again, you should know its basic thing. How to check? How to check? Diode is forward and reverse. Okay. So again, Nihar, Umakant. Okay. Okay. Karthik, Apurva. Okay. Anushka, A. Let's check. If we have a diode now, if we have a diode, method number 1, you have to check if this is P side and this is N side, right? So if potential of P is higher than potential of N, diode will be in forward bias. And if potential of P less than, or you can say potential of P is less than potential of N, this will be in reverse bias. It's a very simple and basic approach. Okay. Even you can you can remember this thing in a other way. What is that other way? Like if we have a diode like this, you can check the direction of current. You can check the direction of current. If current is flowing in this way, diode will be in forward bias. If current is flowing just opposite, if current is flowing like this, so this will be in reverse bias. Now, based on all these property, you can check here. So clearly this is a diode. Here P voltage is less than N voltage now. So it cannot be answer. If you see option number B, minus 2N, here again, plus 2 is having higher value than minus 2. So B cannot be answer. C, yes, C is the correct answer. And D, obviously D cannot be answer. Now just tell me one more question. Yes, so option C is the correct answer. If we have a diode, minus 5 volt, minus 2 volt. Forward biased or reverse biased? This diode forward biased or reverse biased? Tell me. This is forward biased or reverse biased? Reverse biased, Afia is saying. Forward, reversed, reverse. Okay, so again, you guys are giving mixed response. So what I told you now, you have to check. You have to check. So in magnitude, if I take only magnitude, so 5 is higher than 2. But when we are adding negative sign now, so we can say this time potential of P, if this is P side and this is N side, so VP is less than VN. And if this is condition, then it is reverse biased. I know you guys get confused. That's why I've taken this example. So I hope now this thing is clear. Clear, everyone? Why this is reverse bias? Okay, good. Now understand, that's very good. One more example. Okay. So instead of example, I'm just explaining with the help of a question. Okay. Yes, yes, I can give. Don't worry now. You need to find current. Okay. And I'm making a circuit. Question is, obtain the value of current in this branch. Value of I. I'm giving you 2 minutes time, guys. Quickly obtain answer, because once you are able to solve this question now, then you can solve any question based on diode and resistor combination circuit. Obtain the value of I. Quickly. Okay, Anushka. Okay, fine. So even you can ask your doubt. Afia is saying 5 ampere. How to understanding the circuit diagram? Okay, I will explain, Meghna, don't worry. So now she's also saying 5. Okay, 5 ampere. Guys, we have to check which diode is in forward bias and which diode is in reverse bias. Yes, 5 ampere is the correct answer. Now, if this is D1 and this is D2, first you need to check all the diodes are in forward bias or in reverse bias. So now tell me about D1. D1 in forward bias or reverse biased? D1 forward bias or reverse bias? D1, I'm just talking about D1. D1 is in forward bias or reverse biased? Forward bias. Okay, good. And how about D2? D2? D2 is in reverse biased. D2 in reverse biased. Okay. If nothing is given, guys, if nothing is given, so what we consider diode as ideal. We'll consider diode as ideal. Means we have to replace this diode by short circuit and we have to replace this diode by open circuit. So now equivalent circuit will be like, now this is the equivalent circuit. How D2 is reverse bias. Okay, Sonakshi, I will take your point. I will explain that thing. But if assume that D2 is in reverse bias, then this is the circuit. Okay, now in this case, current is how much? So clearly we can say current is equal to 10 by 2. That is 5 ampere. So this is the answer of this particular question. Okay. Now the confusion is how to check D2 is in forward bias or in reverse biased. It's a very simple way. If I'm taking this 10 volt battery, okay, same timing, Kalpana. Now this is 10 volt battery, 10 volt battery. Can I say 10 volt battery? This is a positive plate and this is a negative plate. Positive plate and negative plate. So if we compare voltage at this point, so definitely if this is A point and this is B point, so VA will be higher than VB for sure. Why? Because this A point is connected with positive terminal and B point is connected with negative terminal. So definitely potential of A is higher than potential of B. And if we know this thing, then diode N side is having higher potential and P side is having lower potential. That's why this is in reverse biased. Okay, Sunay, Sonakshi, got it? Okay. So I hope this question is clear to everyone. Even you guys saying assignment. So what you can do, you can solve previous year JEE previous year paper. You will get such type of questions, right? So you guys can practice. Okay, that's good. Now, what about this question? Yeah, Karthik. Guys, think about this question. Tell me which one is correct option here. Which one is correct? Sonakshi, how actually so I can draw a question, but if thereafter you will ask for their explanation and all. No? Right now I don't have question. I can frame questions, but what happens? You need to solve and then check their solution. So it is a lengthy process. So what you can do, you can just refer to JEE previous year paper where you get solution, answer everything. Okay. So guys, tell me what about this question? Which one is correct option? Identify the semiconductor device whose characteristics are given below. Okay. So Umakant is saying A, B. Okay. Sonakshi is saying B and Meghna A. You think, okay. So obviously, whatever we are thinking, we are okay. So guys, now I'm just explaining this thing. Try to feel this thing. What is the D option? Apurva, I will explain each and every option. Don't worry. Okay. Let me just tell you basic thing. So it is like we have a diode and I will explain. Don't worry, guys. Just diode. First is PN junction diode. D option correct. Okay, we'll check. And this is Zener diode. Why we are using Zener diode? You need to understand this thing first. Because what happens when we are using a normal PN junction diode in reverse bias, breakdown takes place and we won't be able to use this diode, right? So that is the demerits of this diode. That's why we are using Zener diode, which can work in reverse bias region properly, which can work in reverse bias properly. So if we talk about yeah, Princess, I'm explaining this thing. Don't worry. I'm explaining same question. Okay. So if we talk about normal PN junction diode, its characteristic is like this. And here, this is a breakdown region. So this is not desirable region. Okay. But if we talk about normal PN junction diode, its characteristic is like this one and this one. So now tell me, if my question is, we want to operate in reverse bias region as well as in forward bias region, which diode we need to pick? PN junction diode or Zener diode? Yes, respond. Zener diode, exactly. Zener diode. So now coming back to this question. Here, in first, this one is not shown properly, but here reverse bias clearly shown, and this thing is similar in both the case. So can I say first one is PN junction diode and second one is Zener? Right now? So now let's see. First one is PN junction diode, simple PN. So only in option number D. So D is the correct. No need to check. But if we have such type of configuration, so what we can say, yeah, this is the fourth quadrant now. So in fourth quadrant, graph of solar cell lies. And LDR, guys, LDR is basically a special type of resistor whose value changes with the intensity of light. That's why we call this as light dependent resistor. But no need to check. Out of one and A and B only, you can get correct answer. So correct answer is option number D. Any doubt, feel free to ask. Same timing, Sonakshi, same timing. Okay, guys. So I hope you guys are able to understand things properly. Okay, then. Bye-bye. All the very best for your coming exams. Take care. Bye-bye.